Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 13 video on the chapter of mensuration, where I will solve the remaining problems of exercise 20B, that is the problems 14, 15 and 16, which are based on finding the area of a shaded region where the region is made up of some rectangular figures. If you have not watched the previous 12 part videos on the chapter of mensuration, then I highly suggest and request that you please watch those videos also to maintain the continuity of your study on the chapter of mensuration. This video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the question number 14, 15, 16 of exercise 20B from the chapter of mensuration. Okay, so on the left hand side, I have kept as a reference the key concepts and formulas that I have discussed so far, which are the area, perimeter, diagonal of square, rectangle, area of four walls of a room and its diagonal, and finally area of a path of uniform width along a rectangular plot of dimension L and B of given dimension. So these are the concepts, even though I have also covered how to find area of a shaded region which is made up of some rectangular figures in my previous some previous video. Okay, so question number 14, we have two figures. We have to find the area of the shaded region. Now in figure 1 you can see that the width is not uniform. It is kind of a path which is outside some rectangular plot. So first of all, whenever you have to find the area of this kind of shaded regions, always name the vertices or the corners of the figures so that you can refer the rectangles properly while solving the problem. So let's say for the figure 1, the outer boundary, the outer rectangle B, PQRS be the outer boundary of the shaded region, and let's say the inner boundary, that is the inner rectangle B, AB, CD. Now clearly you can see in the diagram that the width is not same, the width is not uniform. Parallelly, the width of the shaded region, parallel to the length, parallel to BC R is 1.5 meter, but the width vertically, that is parallel to the side AB, ER 1 meter. So anyway, so I cannot apply, as you can see on the left hand side, I have some formula I already discussed for when the path is outside the rectangular plot and the path is inside the rectangular plot, and the path is having a uniform width. We have the formula, the area of the plot will be for when the path is outside the plot, it is 2x multiplied by L plus B plus 4x square, where x is the uniform width of the path and L is the length of the plot and B is the breadth of the plot. Similarly, when the path is inside the rectangular plot, the formula is this is formula I have derived. In your school exams you cannot apply this formula directly. You have to solve it manually. That is, you have to subtract the area of inner rectangle from outside rectangle. So when the path is inside the rectangular plot, the formula for its area is 2x multiplied by L plus B minus 4x square. Now this formula will work only when the path is having a uniform width, but in the figure 1, as you can see, the path is not having uniform width, so we have to solve it manually. So what will be the area of the shaded region? So area of shaded region, this is based on area between two rectangles. We can say the area of the shaded region will be equal to the area of the outermost rectangle, that is PQRS minus area of the inner rectangle, which is ABCD, Now, in the figure, the dimensions, the length and breadth of the outer rectangle is given, that is PQRS is given. So, and from the width of the shaded region, both vertically and horizontally, we have to find the dimension of the inner rectangle, that is ABCD. That is ABCD is the, you can also say ABCD as the inner boundary of the shaded region. Okay. So, area of PQRS is nothing but PQ multiplied by RS. And what will be area of ABCD? ABCD, it will be AB multiplied by BC. Okay. Now, this is PQ. The length of PQ and RS, not RS, but PQ and QR. The length of PQ and QR is already given in the figure. Okay. Now, what is AB? What is AB? AB will be PQ minus 2 into the width of the shaded region vertically, that is 1. The width of the shaded region, this width and this width is given to be 1 meter. So, AB will be PQ minus 2 into 1. Okay. And what is BC? Similarly, BC will be QR minus 2 into the width of this width. It is same. This width and this width, these are same, and it is 1.5. So, 1.5. Okay. So, this is equal to, now we can put the values of the length PQ and QR. Okay. So, PQ is given to be 27 multiplied by QR is given to be 43, and we have minus okay. So, no, before entering the value of PQ and QR, I think we need to simplify this, because PQ into QR will cancel out. So, let's leave it like this, PQ into QR, and let's simplify the second term, that is the product of the, that is, so this is PQ minus 2, and this is QR minus 3. Okay. This is equal to PQ multiplied by QR. If I do the product of the second, if I do this product and open the brackets, I get this will be PQ multiplied by QR. This will be plus 3 PQ, and this will be plus 2 QR, and it will be minus 6. Okay. Now, for these problems, I forgot to write down the answers. Anyway, I hope I will not make any mistakes. If I do any mistake in calculation, or if I come up with wrong answers, I will appreciate if you please let me know in the comment section. Okay. So, we have, let me quickly check if this is correct or not. PQ multiplied by QR minus PQ multiplied by QR. We have plus 3 PQ, we have plus 2 QR, and okay, this is right. Okay. So, PQ into PQ multiplied by QR, these two gets cancelled out, and this is equal to 3 PQ plus 2 QR minus this much meter square. Now, we can enter the value of PQ and QR. So, this is 3 multiplied by PQ is 27, and 2 into QR is 43, and we have minus 6, this much meter square. This is equal to 81 plus 86 minus 6, meter square, and this is equal to 161 meter square. So the area of the shaded region is 161 meter square. So this was for figure 1. Now in the figure 2, we have to find the area of the shaded region. So basically you can see that it's a square. The outermost rectangle, let's say the outermost rectangle B, P, Q, R and S, and let's say and there are two, you can consider the white regions as roads running parallel to the length and breadth of the square, and the width of the roads are given. One width is 2 meter and the another width is 3 meter. So you can see, so what we will do is we will compute the area of the square PQRS, and then we will subtract the area of the white region. Now the white regions, you can consider them as two roads running parallel to the length and breadth, but they have a overlapping region. This is the overlapping region. This need to be when we will find the area of the white region, that is, if you consider white region to be two roads crossing at right angles and running parallel to the length and breadth of the square, then their total area, while computing the total area, we will have to subtract the overlapping region once. So let's name the area white region. So let's say this be PQRS, let's say this be A, P, C, D, E, F, G, H, I, J, K and L. Okay, I really have very little space I have to manage. Okay, so what will be the area of white region? So the concept we will apply is that we will find what will be the area of the shaded region. It will be the area of the whole square, the whole figure, that is the square, minus the area of the white region. So area of the white region will be equal to area of the rectangle AGHB, that is the, you can consider the road which is running parallel to the which is running vertically, which is vertical, plus area the rectangle IJLK, that is the road which is running horizontally and having a width of 3 meter, minus we have to subtract the common region once. Since if you add up the area of the two area of rectangle AGHB and IJLK, if you add them up, then you are adding the common part, the common region, which is CEFD twice. So we have to subtract this overlapping or common region once. Okay. Now what will be the value? What is the area of AGHB? AGHB, its area will be, its length is the length of the square. So 40 multiplied by HB is nothing, and the width is 2 meter. This plus what is the area of the rectangle IJLK, that is the white region, the white rectangle running which is horizontal or running parallel to the you can consider it is horizontal. So its area will be 40 multiplied by its width, which is 3, and minus we have to subtract the area of the common part, which is nothing but 2 into 3, that is the product of the widths of the two rectangles which are crossing at right angles. This, so this is equal to 80 plus 120 minus 6, and which is equal to 200 minus 6 is 190. 194 meter square. So this is the area of the white region. Remember that this is the area of the white region. Now to find the area of the shaded region, area of shaded region will be equal to the area of the whole figure, which is the square PQRS, minus the area of the white region, which is 194, this much meter square. Now what is the area of the square? It is 40 multiplied by 40 minus 194, this much meter square. So this is equal to 1600 minus 194, this much meter square, and this is equal to 610. This will be 1506 meter square. So 1506 meter square is the area of the shaded region for figure 2. I am not really checking whether I am doing any calculation mistake or not, because I have not written down the answer, so I cannot verify whether my answers are correct or not. I hope I am doing the calculation right, but if not, if I am doing any calculation mistake and my answers are coming incorrect, then please feel free to let me know in the comment section. I will highly appreciate that. Okay, let's do the next problem. So the problem 15 also, we have two figures. In the first figure, you can see, in the first figure we have to find the area of the shaded region. The shaded region is enclosed in rectangle. Let's name the rectangle to be the outermost rectangle, that is the entire figure, A, B, C and D, and let this point be E, and this point be F, and this point be E, F, G. Okay. Now clearly we can one way to find the area of the shaded region is that I can find the area of the whole rectangle, that is the rectangle ABCD, and then subtract the area of the white region, which is the rectangle GBFE. But I know the dimension. I know the dimension of the whole figure, that is the rectangle ABCD. It is given. But can I find the dimension of the white region, that is the white rectangle, that is GBFE? If I can, then I can apply that method. So what will be, I think I can find the dimension of BGFE. So let's see what will be GB. GB is already given to be 16.5 meter, and I need BF. Can I find BF? What is BF? Yes, I can find BF. BF is BC minus FC. Now remember that this kind of problem you can solve it various methods. That is, you can divide the shaded region into multiple rectangles, possibly having overlapping regions or possibly having no overlapping regions, and add them up. And also another method is that you find the whole region, area of the whole region, that is that area of the rectangle enclosing the entire shaded region, and then you find the area of the non-shaded region, that is the white empty or white region, and then you subtract the area of the white region from the area of the whole region. This is another way. So for the figure 1, I think it will be an easy way to find the shaded region by subtracting the area of the white region from the whole rectangle. Okay, so what is BF? BF is BC minus FC, which is 24 minus 4 meter, which is equal to 20 meter. Okay. So I have found the dimensions of the white rectangle, that is the dimension of the non-shaded rectangle, which is GBFE. Okay. So area. So now what will be area of shaded region now becomes equal to area of the whole figure, that is the whole rectangle, which is ABCD, minus area of the rectangle, area of the rectangle GBFE, which is the unshaded region or unshaded rectangle. Now, what is area of ABCD? It is 24 multiplied by 19. Okay. And what is area of a GBFE? It is 16.5 multiplied by 20. So, this much meter square will be the area of the shaded region. Okay. Now, for doing the calculation, I will not do the calculation manually. I'm using a calculator. I'm really sorry for this, but you must always do the calculation manually. Okay, so this is 456 minus this will be 10, 13, 130. So this is 130. This much. No, this is not 130, but this will be 330. Okay, so this much meter square, which is equal to 6 and 2 and 126 meter square. So the area of the, now I'm really not at all concerned whether I am doing any kind of calculation mistake, but just try to understand the concept that I am applying. In doing the multiplication, doing subtraction or addition, if I am doing any kind of calculation mistake, I am not really focusing in that. So possibly I will do some calculation mistake and my answer will come incorrect. But your focus must be how I am approaching the problem and how I am approaching the problem and what concept I am applying. Okay. So it is 126 meter square. Now for the figure 2, it is an E and the dimensions are given. Now the way I would like to do is that I would like to divide the entire shaded region into some rectangles which do not have any overlapping region. For example, I will make this rectangle. Okay, this rectangle. Let this rectangle be A, B, C and D. That is the vertical rectangle, and then I will have the rectangle D. This is E, this is F, this is G, and let's say G. This is H, this is I, this is J, and this is K, and let's say K. This is L, this is M, and this is N. So I have just so the rectangle. So you can see that the area now. Now let's first figure. Let's first find out the dimensions that I will need to find the area of the 4 rectangles. So the 4 rectangles that I have created, or the shaded region can be divided into 4 rectangles. This one, this one, this one, and this one. Okay. So I need what is AD. I need AD to find the rectangle which is vertically downwards. That is the rectangle AB, ABCD. AB is known. AB is given to be 15 centimeter. What will be AD? Okay. So this width is given to be 3 centimeter. So clearly AD will be 15, not 15 but 12 minus 3, which is 9 centimeter. So AD is 3 centimeter. I'm sorry. AD, I need AD. So AD is 3 centimeter. Okay. So I know AB and AD So I then can find the area of the rectangle ABCD. Now I need for the rectangle DK for the rectangle for the rectangle DEFG I need DG is equal to AG minus AD. AG is 12 centimeter, so 12 minus 3 is equal to 9 centimeter. So DG is equal to 9 centimeter, and I need GF. GF for DE. GF is equal to DE. Its dimension is also given to be 3 centimeter. Okay. How will I know 3 centimeter? Centimeter. How will I find kg, kj or hi? How will I find this one is the whole length is 12 centimeter. I will quickly check whether I am missing any information from in the figure. Sorry friends, let me quickly check whether I am missing any information in the given problem. Okay, so I am missing one information, which is this length is 5 centimeter. Okay, so that's what I was wondering. How will I find? So kj is given this length. I'm really sorry, my figure has become very congested. This length is given to be 5 centimeter. So kj is equal to 5 centimeter. So once I know GF, once I know okay, kj is equal to 5 centimeter. Okay, what else do I know? Okay, so I think it's we have enough information to find the area of all the rectangles. So what will be the area of shaded region will be equal to area of the rectangle A, B, C or D plus area of the rectangle DEFG, that is this part DEFG plus area of the rectangle KHIJ plus area of the rectangle LCMN. Now please note that the rectangles DEFG and LCMN, they will be congruent, they are identical. Okay. So what is the area of rectangle ABCD? It is 15 multiplied by 3. It will be 15. This is equal to 15 multiplied by 3. What is the area of rectangle DEFG? DEFG, it is DG. DG is 9 centimeter multiplied by 3. So 9 multiplied by 3 plus what is area of rectangle KHIJ? KHIJ, it is 5 centimeter, 5 multiplied by 3, 5 multiplied by 3, and the area of the rectangle LCMN is identical to the area of the rectangle DEFG. So it will be 9 multiplied by 3. Okay. So this is equal to, I can say, 45 plus 5 into 3 is 15 and 27. 9 into 3 is 27, 27 multiplied by 2, which is equal to 60 plus 54, which is equal to 114 meter square. So 114 meter square is the area of the shaded region. So the idea was to divide the shaded region into rectangles, into 4 rectangles, and these 4 rectangles do not have any overlapping region. So I can add up the individual area of the 4 rectangles, and that will give the area of the entire shaded region. Okay, let's do the last problem. So we have to find the area of the shaded region. This is a kind of stairs where the height of each stair is 0.5 meter, 0.5 meter, and also the length of the bottommost rectangle is 3.5 meter. Now it is not given. It is not given in the book. What is the length of this? What is the length of the second rectangle from the bottommost part? That is the second largest rectangle. What will be the length of the second largest rectangle? I think it will be, this length, that is, if I extend this line, this length, this width is also 0.5 meter. Only then we can find the area. This is 0.5 meter. Okay, so let's name the rectangles. Let's say the bottommost rectangle be A, B, C, D, and let's say the second largest rectangle be E, F, G, H, and let's say the third largest rectangle be I, J, K, L, and the smallest rectangle be M, N, O, P. So clearly we can see that AB, so AB is given to be 3.5 meter, and also AC, its width is 0.5 meter. So these are the dimension of the largest or the bottommost rectangle. Let's find the dimension of the second largest rectangle. So let's say the length if G is equal to the length of the rectangle below it, that is the largest rectangle, minus, so it will be AB minus 2 into 0.5, this much meter, because the side EF is 0.5 meter apart from the left edge of the rectangle, of the bottommost rectangle, and also the rightmost edge of the rectangle EF GH is also 0.5 meter apart from the rightmost edge, the right edge of the largest rectangle. Okay, so this is equal to, what is AB? AB is 3.5 minus 1 meter, which is 2.5 meter. Okay, so this means that the length of a rectangle, rectangle will be 1 less than the rectangle below it. So okay, FG, and what will be JK? That is the length of the rectangle uh, above the rectangle EFGH, that is the length of the third largest rectangle JK, will be FG minus 2 multiplied by point F this much meter, and FG is nothing but 2.5, and we have minus 1, which is 1.5 meter. And finally, what is NO? NO will be JK minus 2 multiplied by 0.5 meter. This is equal to 1.5 minus 1. This is equal to 0.5 meter. So now area of shaded region, is equal to area of the bottommost rectangle, which is ABCD, plus the area of the rectangle above it, which is EFGH, plus the area of the rectangle above it, which is IJKL, and finally the area of the topmost rectangle, which is MNOP. Okay. So now this is equal to the area of ABCD. The bottommost rectangle is 3.5 multiplied by 0.5. Now remember one thing, that okay, let's put all the values. The width of all the rectangles are same, and they are all 0.5 meter. Area of EFGH is, its length is 2.5. So we have 2.5 multiplied by 0.5. Similarly, we will have 1.5 multiplied by 0.5, and finally we will have 0.5 multiplied by 0.5. So as you can see, we can take 0.5 common from all the terms, and we have 0.5 multiplied by 3.5 plus 2.5 plus 1.5 plus 0.5, this much meter square. So this is equal to 0.5 multiplied by 3.5 plus 2.5 is 6, and 1.5 and 0.5 is 2. So this is 6 plus 2 meter square. So this is 0.5 multiplied by 8 meter square. So this is 4 meter square. Okay, so this is 4 meter square. Now I will quickly check whether the answers are correct or not. 20B 14, for question number 14, first figure, the area is 161 meter square, it is correct, and the second one, area is 1406, but in my case my answer is 1506. So definitely I might have done some calculation mistake, which I will not see. Definitely there is a calculation mistake. It might be should be some minor mistake, because the answer is 1406 meter square and my answer is 1506 meter square. Okay. For question number 15, for figure 1, the area is 126 meter square, that is fine, and for figure 2 it is 114 meter square. 114 meter square, it is fine. So question number 15, both the parts my answers are correct. Okay. Question number 16, the area is 4 meter square, it is correct. Okay. So these were very straightforward questions, only not too difficult, only that you have to observe the given shaded region and divide the shaded region into some rectangles. Possibly you will always try to divide the entire shaded region into rectangles that do not have any overlapping region, but in some cases it may not be possible to find the area of a region, whether it be shaded region or whether it be empty region, where you have divided into rectangles, but the rectangles are having some common region. And the other concept is that whenever you are asked to find the area of a shaded region, either you can divide the shaded region into some rectangles and then find the area of those rectangles and add them up, or you can find whichever is easy, or you can find the area of the non-shaded region, that is the empty region, and subtract that area from the area of the whole figure, that is the enclosing rectangle or square. I hope solving this problem will give you some insight, some guidance of how to solve this kind of problems. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So, with this 14, 15 and 16, I have completed in solving all the problems of exercise 20B. In the next video, I will proceed to start with the next topic, that is how to find the area of, I will discuss about the area of parallelogram and rhombus with some illustrative examples. And also, okay, and once that is done, I will give some concept practice problems, set number 3, which will be based on the area of parallelogram and rhombus. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.